David.
I'm Nick.
And our project was the city scanner and mapping their environment using Vicinity. So basically our project focused on having our scribble robot to scan the environment in order to map out its surroundings onto the computer. So first, our purpose of this project, the big picture, was we wanted it to be like a robot that can actually aid firefighters in their duty, because they actually risk their lives running into like burning down structures and help save citizens' lives. So we thought it'd be really cool if we could actually have something to help them. So yeah, we wanted to be able to find paths or routes that could actually go through around fires.
So how this is going to work? First, the project must turn 15 degrees increments in a full circle 360 degrees in order to record all the obstacle data from itself to the walls. And second, it has to convert the polar coordinates into linear coordinates with and height and degree angles. And third, it has to get it calculated and the recorded data in order to map out the environment on the computer.
So our code, we used 3 different libraries. The first library is the graphics library, which we use that for graphing the actual surroundings onto the computer. And then second, the Maro library was actually controlling the robot, which started in like built-in systems or commands that we can actually use, like turn this many degrees every time. And then our math input line was our trigonometry part of our project, where we actually had to convert points so we can actually graph them. And right here, the first part of the code, define obstacle, is actually what we use to measure the distance between the robot and the walls around it. We got the average of every reading per second.
Besides obstacle function, there are also 2 other important functions, which is record obstacle and draw. Record obstacle means for 49 seconds, which is the time it takes for the robot to turn in the full circle 360 degrees. For the 49 seconds, every second it has to record the average of the obstacle reading every second onto the array obstacle reading. And for a draw function, it will take every element out of the array that was just recorded, and it will plot the points onto using an algorithm which David will explain later.
So this is our algorithm. So this is what we came up to in order to change the radians into linear points, because we wanted degrees. It's a lot easier to graph this way. So using excess of distance, because every time it turns 15 degrees, we use sine and cosine. So sine is the height and cosine is the width. So we use that in order to graph our points.
And this is our main piece of hardware that makes this project work. And as complicated as this seems, we only use this sensor, the one in the middle, the infrared sensor. And basically how it works is that it will send out infrared waves, infrared rays, and it depends, and it records on how much infrared wave will bounce back. The more that bounces back means more there will be an obstacle that was close by, and the less number means less infrared ray that will bounce back means there will be no obstacle nearby.
So as you see on the left side, it's actually the robot is turning increments of 15 degrees, and it's actually recording the distances per second.
And here is the results of the robot. And as you can see, there will be a line right here, which means that this box is an obstacle right here, and there's another line right here that means another obstacle right there. And as you can see, there are a bunch of points right here, which means there are no obstacle around, so there will be no lines with points, since there will be an infrared reading of 0. And for the results, what we got out of this project, we will accurately plot the area around the robot. And we are also able to convert its polar coordinates that was recorded by the robot onto linear coordinates, which is width and height. And at last, we can plot out the points on the map, which is recorded on the computer.
So in conclusion, it was very successful actually. The robot was able to see readings up to 12 inches. That was actually pretty good for this robot, because it's actually really small. And it's actually sort of limited in what we can do, because it has to be in a fixed location every time we start the program. But yeah, I thought we were successful in what we wanted to accomplish. And with further research, like it has so many possibilities, like not just for like aiding firemen, like we can do so many different things that go into like excavation sites, or like even like map out surrounding people using the military.
And we would like to thank especially Riley and Magnus and the rest of the faculty. And Riley and Magnus gave us the idea of this project, which without them, we can't come with this idea. It's a really special project. And Kurt really taught me how to program this project using for loops and stuff, all the special functions in Python. And Sarah, we talked about the Arduino, but it seemed kind of hard, so I'm and Matt gave us the fingerprint, and Ryan saved my computer from a memory card that got stuck in my laptop. Really gave us the idea how to do this clean project presentation. Awesome. Thank you. Here's the video of this project. And you can see it starts right there. It looks like a unit circle. It starts from 0 degrees and moves to counterclockwise. And it moves to 15-degree increments. And you can see this red line will flash. That means it's recording data. Each time it's flashing means it's calculating the average recording data. Here's the end result. Point, and the line will come up later. Thank you.